Hello, in this lesson, our learning target is I can find the domain and range of absolute value functions. So we're going to build off the foundations that we built in our last two lessons on different types of shifts and slope changes for the absolute value function. And we're going to apply those transformations and see how they affect the domain and range of the absolute value function. So first things first, let's just do a little refresher on what the domain and range of a function are. So the domain would be all possible inputs or x values of a function. Our range would be all possible outputs or y values of a function. So again, in the absolute value function, we would have f of x is equal to absolute value of x. That's the most basic absolute value function. So f of x, or y, would represent our possible values from our range, whereas x, our input, would represent our domain. So again, I'll throw it back to some imagery that we used last semester, where we think of the function as a machine. So there's our little function machine. And we have our input here and our output here. So we put x in, and out comes f of x. So to start out, let's look at our most basic absolute value function, which we have right here. F of x is equal to absolute value of x. So as we did in one of our last lessons, our graph is going to look something like this. So our x-axis shows us all of our possible x values. And as you notice, this graph will stretch forever in this direction and forever in this direction. So what that tells us is that we can put in any real number for x, and we're going to get something out of that function. So we could calculate what the absolute value of 1 is. It's equal to 1. Calculate the absolute value of 1,000. It's equal to 1,000. We could calculate the absolute value of negative 1 million. It's equal to positive 1 million. And so on. So we can put in any input again. All real numbers will work for our input. So for our domain, we will have all real numbers, which we can notate either by writing all real numbers. We can notate by writing this fancy R, which is the mathematical symbol for all real numbers, or we can use interval notation to demonstrate that. So if you recall from last semester, interval notation is we would have 4 possibilities. We have our lowest possible value here, our highest possible value here, and depending on whether or not our interval includes our lower and higher bounds, we have either parentheses or brackets. So in this case, our lowest possible value is negative infinity, and our highest is positive infinity. And just by convention, whenever our bounds are either positive or negative infinity, we get parentheses. So that is our domain for this function. our range is going to be a little bit trickier. So we've discussed earlier that when we have f of x is equal to absolute value of x, f of x cannot be negative. And that is notated on our graph right here. So what we want to do is look at what is our lowest possible y value. And the answer to that is 0. Our absolute value function, the y value, cannot go less than 0, i.e. it cannot be negative. So since our answer includes 0 itself, we're going to use a bracket this time. We're going to put 0 since that's the lowest possible value. And y could be as big as we want it to be if we make x really big too. So our upper bound is going to be infinity. So this is going to be our answer for our range, whereas this is going to be our answer for our domain. And when you're writing down what the domain is, you can use any one of these three options. So that is how to find the domain and range of the basic absolute value function. We want to take things a little bit further and look at our shifts. So one pattern that we'll start to realize is for any sort of absolute value function. So we could have it shifted this way. We could have it shifted this way. We could have it shifted up. We could have the slope changed and it shifted like this. For any possible absolute value function, our domain is always going to be all real numbers. So I'm going to write that in big letters. For any absolute value function, domain is all real numbers. And that is because no matter what we do to this function, it's still going to go on forever in the negative x and forever in the positive x. And really what that means is we can plug in any x value we want, and there will be a corresponding output for it. So for any absolute value function, the domain is all real numbers. But how about the range? Again, like we said earlier, the range is a little bit trickier. So our range depends only on vertical shifts and/or flips. So a vertical shift. Let's look at f of x is equal to absolute value of x plus 6. So now we have our regular run-of-the-mill absolute value function, but we're shifting it up 6 units. So by looking at our graph, we can see that our lowest possible value is positive 6. And again, going upwards, it stretches into infinity. So our highest possible value is infinity. So that would be the range for this function. How about f of x is equal to negative 3 times absolute value of x? If we graph this one, it's going to look something like this. So now, our lowest possible value, it could be as small as we want, because if we make x really, really big, we're going to have a negative 3 times a really big positive number, which could be anything down to negative infinity. And our highest possible number is going to be 0. And again, since our answer includes 0, we'll make a bracket here. So that is the range of that function. So you see here, the flip, which is represented by this negative sign, makes it so that our v shape of the absolute value function is inverted, and that's again why our range is switched to being a range from any huge negative number like negative infinity up to 0. And then we could combine these two types of flips. So if we have, say, f of x is equal to negative x minus 3, that's going to look something like this. What's our lowest possible value? It's negative infinity. Our highest possible value is now negative 3. So that would be our range. And again, for every single one of these functions, our domain is going to be all real numbers. And another thing to keep in mind is that horizontal shifts do not change either the domain or the range. Because if we have, say, f of x is equal to x plus 4, that's just going to move our absolute value function to the left 4 units. And we can see our domain is still going to be all real numbers, and our range is still going to just go from 0 to positive infinity. So that's a couple examples of how to find the domain and range of absolute value functions. And once you get the feel for how these transformations and shifts of these graphs work, you'll realize that you don't have to graph the function every time. Just by looking at this function, you'll know, oh, okay, I'm shifting the absolute value function up 6 units, so our lowest possible value for y is going to be 6, so our range is going to go from 6 to infinity. And you'll get the hang of figuring it out really quickly. So in our next lesson, we're going to go over graphing absolute value inequalities. So stay tuned for that.